All right, good evening, everybody. Welcome to our Red Barn event for the evening. All right, my name is Tucker. I'm a community programs educator here. Thanks again for being here for our Red Barn event. And we're trying out a little bit of a new format here, so thanks for being here. And I think it's gonna be a really great talk. So just a couple things about Wenatchee River Institute. We are a nonprofit with a mission to connect communities, people, and the natural world. And you being here is part of our mission. So thanks again for being here. I want to introduce Joshua as well, who's a fellow community programs educator. He's going to be working the technology here, and there's going to be people watching at home as well. So Joshua's making that happen. And also, Lissy over here serving drinks. Thank you, Lissy, for being here. So for our mission of connecting people, communities, and the natural world, we have kind of two branches of things that we do, youth education and community education. Our youth education, we have all sorts of things going on with local school districts right here in Leavenworth, as well as throughout North Central Washington. And we have Dee Butcher in the back. Here's our youth programs educator. Hello, Dee. And our community programs, range from events like this, our Red Barn events, to other workshops and seasonal walks. And we have a lot of things going on. Our next Red Barn event is going to be on December 13th, and that's our last one for the year. And then we've got a pretty full schedule of Red Barn events coming up in January and February, so keep your eye out for that. A couple other things happening at the start of the new year is our snowshoe strolls, which are all throughout January and February on Fridays and Saturdays. And we're also looking to restart a Science on Tap program where we're going to have speakers come in and give a talk at a local bar. Most of these are going to be happening in Wenatchee and trying to kind of expand our presence down there too. So keep your eye out for those events coming up in the new year. And another aspect of WRI is our effort to connect the indigenous peoples to their ancestral lands. So I'd like to take a moment to read our land acknowledgement here. This land acknowledgement was created alongside the Shimpishquashu people. We're spreading the message they wish to be spread to the public. The land Wenatchee River Institute sits on is the ancestral homelands of the Shimpishquashu, or Pasquosa or Wenatchee people. The Shimpishquashu, meaning people in between, had villages positioned along the Wenatchee River and surrounding areas. Their ancestral homeland extends from the Cascade Ridge throughout what is now known as the Wenatchee and Okanagan valleys. The culture and economy of the Shimpishquashu people centers on taking care of the land. They fish, hunt, gather roots and berries, basket-making materials, and medicines. The Shimpishquashu are named within the Yakima Treaty of 1855. Language to establish the Wenatchee Reservation was never followed through, even with the needed surveying completed. Many Shimpishquashu now live on the Colville Reservation, 150 miles northeast of Leavenworth. They were forced off their land here, and the U.S. government moved them to this reservation. The Shimpishquashu people are still alive today. They continue to practice their culture, harvest their traditional foods and medicines, and hold their ceremonies passed down from their ancestors. Most people won't see or notice them, but they continue to be on the land they're connected to. Their traditional language is Inhamchin, an interior Salish dialect, and we would like to welcome you all by saying hello in their language, Tilhusht. We offer this land acknowledgement as the first step to amplifying indigenous voices and recognizing the harm done to them as a people. We stand as an ally to recognize their connection to the land and their rights to practice their culture on these sacred lands. We encourage all to learn about the indigenous peoples of the place you call home. Wenatchee River Institute is committed to sharing this land acknowledgement and following up with other actions to educate and be respectful. All right, thanks everybody. One other really important thing in addition to you all coming here for our Red Barn event, is our sponsors for our Red Barn events. We wouldn't be able to put these on without our sponsors, so I'd like to take a minute to recognize our great local sponsors that make these Red Barn events happen. So you'll see the logos up here. We've got City of Leavenworth, Rhine House, Icicle Brewing Company, South Restaurant, North Central Washington Audubon Society, Munchen House, Sleeping Lady Mountain Resort, Sage Mountain Natural Foods, Gustav's, Obertal Inn, Chocolat, Barron House, Cove Resort at Fish Lake, Tierra Learning Center, Riverfront Rock Gym, and Rimmer and Reuter Construction. So thank you to those sponsors for making these events happen. Yeah. So as I mentioned earlier, Joshua here is going to be on our tech side of things. So we do have some people who are tuning in from home. We're going to have our presenter up here on the screen, and I'll just ask that if you're here in the audience that you save questions until the end. So we will have a chance to ask our presenter some questions. Since this is a new format, we're going to just try this out. But I think what we'll do at the end is have this podium over here in front of this computer so that you can kind of ask the question to the presenter. So we'll have you come up if that's all right. I think that'll be the best way to do it. And then if you're watching at home, we'll be monitoring the chat, so you can just put questions in the chat and we'll ask those at the end as well. So without further ado, I'd like to introduce Joan Frazee, who's our chair of our local chapter of the Native Plant Society. All right. Hi, Joan.
Hi. Thank you, Tucker. So welcome, everyone. We're just really excited to be back here at the Red Barn, partnering with Wenatchee River Institute and amazing technology ability that they have to allow us to have you here in person, as well as having you out there in Zoom land. So I just want to welcome everyone. And who are we? The Washington Native Plant Society. It's a statewide organization. There's 12 chapters across the state, and we have our very own chapter here in the Wenatchee Valley, the Wenatchee Valley chapter. And I'm Joan Frazee. I'm the chair of the local chapter, serving as the local chapter chair. And chapter news, right now we have nominations are still open for Plant of the Year. We like to highlight a native plant every year, and so if you've got an idea, a favorite plant, something special, native plant, go ahead and send an email with photos and your rationale to Wenatchee Valley WNPS@gmail.com. We've got more programs coming in January and February. January, we'll have a talk on golden paintbrush, and in February or March, the flora of the Palouse. So without further ado, I will introduce our program co-chair, Mr. Ted Alway.
Thank you. Good evening, everyone. It's good to see you all here, and all of you at home as well that are taking this in. I'm excited about tonight's topic. I have a particular interest and joy in going to alpine areas and learning about the flora there. And who better to tell us about this than David Giblin, who's spending quite a bit of time in the mountains, learning and documenting what's there, and knows our flora very well. In fact, he's been to many peaks in the Wenatchee Mountains, documenting the flora. And this is part of an ongoing project you'll hear about tonight. The 50 Peaks Project is documenting the diversity and the distribution of the flora in the Cascade Range from the Oregon border up to the Canadian border. And he's now in year 4, will be entering year 4 of a 5-year project. So 50 peaks will be visited, and they've got 30 under the belt, if I understand right. This is a 5-year study that he initiated in 2021, and it's a comprehensive survey of the vascular plants in the Cascade Range. The goals of this project include improving the knowledge of the alpine species that we have in the Cascades, locating new populations of rare plant species there, creating some baseline data so we can see what we have and document changes, particularly in light of climate change, and providing as well undergraduate students opportunity to learn in the field. It's very exciting for them to do. David is the collections manager and a research botanist at the University of Washington and the Herbarium at the Burke Museum. His research focuses on the distribution and diversity of Pacific Northwest vascular plant flora, which he's done extensive field work with throughout our area. He manages the Plants of Washington Image Gallery. If you haven't seen that, I imagine many of you have. It's a great resource. I come back from hikes and go on there, try to confirm what I think I saw. He manages the Washington Flora Checklist and the Consortium of Pacific Northwest Herbaria online databases. He's the lead editor and co-author of the recently reissued Flora of the Pacific Northwest, second edition, and co-author of Wildflower Guides to Mount Rainier and Olympic National Parks, and the co-creator of the Washington Wildflowers app, which if you don't have, it's also a very wonderful tool. And the Taxon Editor of several families for the Flora of North America project. So please join me to give a warm virtual welcome to David Giblin.
Am I coming through okay? All right. Okay, great. Thank you, Ted, for the very generous introduction, and thank you, Ted, and everyone in the chapter for inviting me to speak tonight. It's always an honor, and I'm always flattered to be invited to talk about something I'm interested in. And tonight, I'm going to talk about my most recent project, which is the 50 Peaks Project, which Ted gave you an overview. And as much as I would love to be there in person, I just took a look at the past webcam, and I guess I'm sorry not to have missed an exciting trip over the pass. But let me share my screen here and get started. And so my goal is to speak for about 45 minutes and then have questions and answers afterwards. The 50 Peaks Project, we're attempting to do is explore patterns of alpine plant diversity in Washington, primarily Cascades Range, although if I have time at the end, I can talk about some broader studies associated with this one. And just in terms of an overview, I'm going to give you a really quick background about the herbarium here for those of you who may not be familiar with it. I'll talk about the background of the 50 Peaks Project, which Ted did a nice job summarizing. Talk about a little bit of data analyses, and then the last bit is a little bit of hand-waving as to why the patterns of species distribution might be the way they are. So a little bit about the herbarium. It's a botanical research collection. My area of expertise and interest is vascular plants. The collection here was started in the late 1800s. We have about 400,000 vascular plants. Specimens, and this is a specimen here on the right. It's very typical, 11 by 17 inch sheet of paper with a plant and with a label. And if you look at the label, it provides important information, the scientific name, when and where it was collected, some information about habitat ideally, and now we have geo-coordinates that we can pull from our phones, lat longe values that allow us to plot them. Though my current project is in the alpine, this gives you an idea of the field work I've done over about the last 20 years across Washington in an effort to document diversity and distribution of the vascular flora here. And so those data we make publicly accessible online through a website that we call the Consortium of Pacific Northwest Herbaria. There's about 50 collections throughout the Northwest that are contributing over 3 million specimen records and 1.5 million specimen images. So this is a really great way to create access to the information that we generate through field work. And as Ted mentioned, we also are the originators and caretakers of the Plants of Washington Image Gallery. The gallery has also images of fungi, lichenized fungi. Altogether, there's over 90,000 images that have been contributed by amateur and professional botanists. Nearly 3,200 species are represented on that site. And if you go to anyone's page, there's a full treatment of its distribution in Washington, photos, close-ups of flowers, growth habit, fruit, and then a whole bunch of information related to distribution, bloom time, whether it's native or introduced. And most recently, we have added information about pollination for most species. So it's a really great resource. All of that information really was the underpinning of our revision of the flora of the Pacific Northwest, which we published in 2018, which is a a technical field manual to the vascular plant flora of Washington, about half of Oregon, most of Idaho and western Montana. There's over 5,000 species, subspecies, and varieties of plants there. And so we have technical keys supported by wonderful illustrations. Okay, so I'd love to tell you more about the herbarium, but that's not what we're here for tonight. So we're going to talk about the 50 Peaks project. And as Ted mentioned, there's some really simple goals. The first is to visit 50 peaks in the Cascade Range from the Goat Rocks up to the Canadian border. And why not the Olympics is because 50 Cascades peaks is a big enough task for me at this point. It provides critical field research opportunities for undergraduate students. They're just incredibly wonderful folks to work with, and they really get a lot out of it. Really, another core thing is to improve alpine diversity and distribution information. And this really came to light when we were writing that flora, is that of all the habitats in Washington, the alpine was the least represented in terms of the specimens available. And it's obvious. I mean, these are hard places to get to, and that explains in part why there are so few specimens. Also, this growing season is short, and it's just... So in an effort to overcome that impediment, I have taken on this project. I'm always interested in documenting new populations of rare plants. I mean, some things are rare because they're truly uncommon, and then other things are maybe we perceive as rare because their range and habitat haven't been thoroughly investigated. So this is contributing to that effort. And then, of course, we would like to create baseline data for future climate change studies in the alpine. And some of this is inspired by a project I'll mention a little bit later, my work in the San Juan Islands, where we created baseline data. And who would have known, like within 10 years, the flora of some of those islands have changed significantly. And thank goodness we had those baseline data. So this is a question that seemed really straightforward to me. And I should say from the beginning, when I started this project, I actually thought I knew something about the alpine and the alpine flora. And what I realized is I confused my interest with my knowledge. So it's really been humbling and rewarding to learn a lot about the alpine. And so the alpine, we here in Washington define, at least for this project, it's the area above the continuous tree line. And it's characterized by short growing season due to lingering snowpack, cold temperatures, and also poorly developed soils. So this is just a little cartoon showing you, the alpine is the highest area, and it is characterized by the lack of trees. And if we take a look at a bunch of peaks that we have visited, you can see that they're actually quite different. This is Middle Tiffany, North Cascades, Three Brothers West, out around where you all are. This is near Snoqualmie Pass, Alta Mountain, and this is near Stevens Pass, Mount Howard. And you can see these are very different looking places. The degree of the level to which the trees goes up is quite different. I've got a few additional local peaks for you all. One is, that got cut off, Pyramid Mountain in Chelan County. We're out there this summer. Mount Pugh, which is near Darrington, is really moist there, very different flora as you get towards the top. And then we were at Rampart Mountain, just outside of Leavenworth this summer. And, you look at some of these places like, oh, there's no plants there. I think we documented close to 70 plant species on Rampart Mountain. So these actually are diverse places. The plants are small, they're spread out, but there's a lot going on there. What is not alpine are places like this. We all know Mount Rainier, and people go up and they see the wonderful fields of wildflowers. This is subalpine. You can see that there's tree line back here. These soils are really well developed. They're rich. The plant growth is lush, and we just don't call this the alpine. So when I think of alpine in Washington, I think of kind of largely a barren landscape. It's not that it's not diverse. It just, there isn't a long growing season. There isn't a lot of soil nutrients. So real harsh environment. So why 50 peaks? Some of it has to do with, seem like a good number. But more, it actually has a basis in some ecological theory. And somebody once said there's one law of ecology, is that species richness increases with area. And that's simply what this curve here shows. So on the x-axis, as you increase your area, you should discover or encounter more species. But you get to a point where the more ground you cover, you're not going to add any more species because it's a finite number. So I'm hoping that after 50 peaks, we will be somewhere out here on this curve, and we will have found most, if not, most of the species that occur in the alpine. So where are we after 32 peaks? This is where we are. Obviously, the first peak adds the most species. So the x-axis is the number of peaks visited, and then the y-axis is the cumulative number of taxa. And taxa is an inclusive term for species, subspecies, and varieties. So really, these big jumps that you get here and here and here are, if you track them down to the map, these are places that we had not been to previously. And so the reality is when you go to new places, and when I say new places, I'm really talking about the ecology, the geology, elevation, these things, you encounter different species because they have a diversity of distributions. So I'm hoping at 50, this will start to flatten out, and then I'll feel like 50 was a good number. But 18, with 18 peaks to go, we'll see. In terms of methods and protocols, as Ted mentioned, it's restricted to the Cascade Range, and we're starting as far south as the Goat Rocks Wilderness, because to me, that's really the last alpine area that isn't on a volcano. So we're not including Mount Rainier, we're not including Mount Adams, we're not including Mount Baker, Glacier Peak. Those are really unique geological features, and they're technical to get to. These are all hikeable peaks from the southern Cascades, which I think of the Goat Rocks being in, up to the Canadian border. Why the Canadian border? Because you need permits and passports to get into, permits to collect plants and passports to get in there. So we are stopping at the Canadian border. If I have time at the end, I have a colleague in British Columbia who's doing the same thing. So that's another reason why we can stop here. So what this is showing is all the peaks that we have been to so far, and they're color-coded by year. So this past year are the yellows, and then the previous 2022 are the blues, and then I guess red is the first year. So we take field notes when we're out there, when we collect. We don't collect everything. Things that are very common and very easily identified in the field, we just checklist, and I'll show you that in a second. But we do make a lot of collections, in part because some things are difficult to identify in the field. We identify everything back here in the herbarium. And we also like some representative samples of some of the things that we're collecting. So this is what the field notebook looks like. We take numbers and make notes about each collection. We have data sheets that we take with us that we make notes about whether the plants were observed or collected, relative abundance, phenology, aspect, and something about the geology. So, we have what we think is really a robust set of data that, again, could be repeated at some point in the future. We also are collecting tissue samples because I have a colleague down at the University of New Mexico, and her graduate student is also working on alpine ecology, alpine evolution. And so we are taking tissue samples of everything that we collect and sending them off there for DNA analyses for phylogenetic and plant community studies. We're also making all the data that we generate available online. So we have a website. That's the URL for the website. Ted has been kind enough to visit it. And so it's really great to know that people are using the website. And so we have species lists for each peak that we visited. Earlier on, I had a student working with Don Schechtel, who was, the students were adding species lists for these peaks to the WNPS plant list database, and I have a student working now who will continue that work this winter. But it's great. You can download and see everything that we have collected or observed on each peak. And again, I mentioned earlier, we have this online database, and we make the specimen data available there as well. for anybody around the world. And we actually contribute these data to a global specimen database that is accessed by people internationally. This project would not be possible without the undergraduate students that I mentioned. I mean, they're just like everything I'm showing you, they largely did. I'm just the most conspicuous face for this whole project, but planning projects, data analysis, specimen identification, specimen imaging, that the websites, and and they present their research at symposia. It's just remarkable. It's one of the great things about working at the University of Washington. So there have been 9 students to date. The first year, it was just 2 of them, Leo and Ava. And then 2, not this year, the previous year, I had 4 undergraduate students, Phoebe, Brielle, Samantha, and Sophia. And this past summer, Intan, Eric, and Nick there, here on the right, were joining me in the field. And AJ was an undergraduate student here who was doing data analysis, and she presented her research at the undergraduate research symposium. So it's just remarkable. They're so much fun to work with, and they really generate a lot of information. And the data analyses that I have a few, not too many, that and the graphs, all the graphs you see, they generated. So it's just really great working with them and what they're capable of. And this is Sophia and Phoebe presenting their research at the Washington Botanical Symposium last March. And hopefully I'll have a student doing the same this spring. All right, so I mentioned data analyses. So I just want to go over some of the general trends that we have elucidated, uncovered in the course of our research. And some of them are pretty interesting. But I just want to summarize what we've done, where we've been. So we've done 32 peaks. We probably should have been at 35, but I got COVID in August. And then we kind of got snowed out at the end of August on a trip. So that ended up eliminating about 3 peaks. But we're up to 32, or slightly ahead of pace. We've collected nearly 1,000 vascular plant specimens. Of those, we have identified 300 species, subspecies, and varieties through those specimens. We have only encountered 1 introduced species on 1 peak, and that is dandelion. And for those in your neck of the woods, if any of you have been up to Hawkins Mountain, that's where we found it. There's actually a native 2 or 3 native dandelions in the alpine, and I'm hoping that we encounter the native ones as part of our work as well. We've hiked about 250 miles and done about 80,000 feet elevation gain. And I just share that, not because I'm proud of it, but that's the effort that's involved to generate this information. I tell people, if I could drive to the top of those mountains, I would, because this isn't a hiking project. But that person also said, if you could do that, this project would already be done. So I'm not complaining. I'm grateful for the experience. But as I say, we're not out there to be hiking and backpacking, but it is the only way for us to get around. Okay, so some of the general findings so far that, as I say, I thought I knew something about the alpine, and what I didn't know is that most of the plants that I see in the alpine are not restricted to the alpine. So this is a graph that we did after 2 years, slightly less than the 300 I showed you. So this is what it says, N equals 237. That's 237 taxa. Of those, only 11% are what we would call alpine specialists. And by alpine specialists, these are species that grow almost exclusively in the alpine. You won't find them in other places. And those are contrasted against alpine generalists. And those are things that mostly grow outside the alpine. I've got some examples here. So nearly 90% of what we have encountered are alpine generalists. They grow in a variety of places. And here's 2 great examples. I'm sure many of you know Phacelia sericea, silky Phacelia. I think of it as kind of an iconic plant here in the alpine of Washington's Cascades. In a lot of those places, you'll also find Oregon sunshine, Eriophyllum linatum. Eriophyllum linatum grows down at sea level. It's throughout the San Juan Islands. It's all along the coast. It's extremely plastic in terms of the environments in which it lives. Other examples are Campanula rotundifolia, Sedum lanceolatum, and the list goes on. So yeah, this has been surprising to me to learn this. Another interesting thing along those lines is that most alpine plants are actually poor dispersers. If you think about these things being across these mountain ranges that are separated by forests and great divides, you think, wow, most of these things are probably wind dispersed or dispersed by birds. Not so. So this chart here, again, breaks things down between alpine specialists and alpine generalists, and it looks at their dispersal mode. And we broke it into whether it was wind, animal, or gravity. And then over here was spores because there's some ferns in there. In both groups, you can see that gravity dispersal is the most common dispersal mode. And by gravity, we mean simply the seeds fall off the plants onto the ground with no active way of them moving around. And a good example of that, well, before I do that, animal, what's remarkable, I think, at least to me, the alpine specialists and alpine generalists really share similar dispersal modes. Even, animals, same number. Wind is slightly more in the alpine than it is in the, I shouldn't say slightly, it's actually about 50% more, which kind of makes sense. Again, to my point that wind would be a good way for things to get around if they're up in the alpine. But a great example of a gravity disperser is alpine spring beauty, one of the plants I think of as being diagnostic or iconic in the Wenatchee Mountains. Those pods, they're capsules, they split open, those little black seeds fall to the ground, and how they got all over the Wenatchees, I have no idea. But they did. It's over time, I guess. Two of the most common and widespread species in the alpine, at least over the area that we've sampled and the number of peaks we've sampled, are conifers. Juniperus communis, mountain juniper, and whitebark pine are two of the most common species, and both of those are bird dispersed. So that's pretty neat. It's pretty neat to see those two species just about everywhere you go. Now, I said that the alpine is above the continuous tree line. That isn't to say that there aren't trees in some of these areas. We found just about every conifer species from the montane up in the alpine. This is Three Brothers West, for those of you who are familiar with it. This would be Navajo Peak back over there in the background, which we visited. But yeah, there's ponderosa pine, there's larch, both species of larch. We've found Picea engelmannii. So there are trees up there, and the birds are certainly helpful for getting those trees around. Okay, so another thing is that, and this is not, I'm sure many of you have heard the idea that alpine peaks are sky islands. And I would say kind of, because, these are islands. This is as I mentioned, I had a project in the San Juan Islands that really kind of served as an inspiration for this current project. In the mid-2000s, I initiated a project with Peter Dunwitty. He and I visited about 70 islands throughout the San Juans, kind of just curious what was on each one of the small islands. But the difference, of course, is that ocean is a really strong dispersal barrier. Things don't get in that water and float to other islands. They die. They get killed by the salt water, whatever. So comparing that with the alpine, and this is an area I'm sure many of you are familiar with. We're standing on Iron Peak, and we are looking north. That would be Teanaway Peak to your left, Bill's Peak to your right. I think Volcanic Neck might be out here. That actually might be it there. But you can see that these peaks are connected by ridge lines. And so in that regard, they're not truly islands, at least many of the peaks in the Cascades. Obviously, there are gaps if you go from the Wenatchees up to the Chewak, up to the Entiats, you go through the Wenatchee Valley. Clearly, they're disconnected there. But a lot of these peaks do have some kind of corridor connecting them. And I'm assuming that serves as a way for things to disperse among the peaks. So going back to the San Juans, as to why I think these peaks are in fact kind of like islands, is this is a graph showing on the x-axis the total number of islands, and on the y-axis the number of species that occurs on that many islands. And what it shows is that most species in the San Juans occur on a small number of islands, and that very few species occur on many islands, right? So there's only about 2 or 3 species that occur on all 60 islands. And it's color-coded here because in that project we were interested in native and looking at patterns between native and introduced species. But nevertheless, in the San Juans, most species occur on a small number of islands, which means you got to conserve a lot of islands if you want to conserve the flora. Well, it turns out there's a very similar pattern in the alpine. So this is through 30 peaks. It didn't include the last 2. But you see the very same pattern, that most species in the alpine area that we've sampled occur on a small number, 5 or fewer. You account for about 70% of the species that we've encountered, and there's very few. This is going to be like mountain juniper and white bark pine that occur on a lot of peaks. So in that way, I would say those alpine peaks are in fact very similar to islands. Okay, so I mentioned one of the goals of the project was to find new rare plant populations, and these are just some examples of the species that we found. Agrostis mertensia, that's a grass. Carex, a sedge. That's actually, this is one of those stories where I said, we thought we had very few records, or it wasn't very common. Turns out that Carex preposita is on a lot of those Wenatchee Mountain peaks. So we really expanded our understanding of the distribution of Carex preposita in this project. Same as with Cainactus thomsonii. It's on the rare plant list, but I mean, we encounter that on so many of the peaks that we've visited. And then Erigeron silicei, which is truly a rare thing. And we encountered it this summer up on Pyramid Mountain, which is just outside of Leavenworth, as I'm sure many of you know, right south of Lake Chelan. And it's not that, the flowers aren't meant to be, they're out of focus for a reason, because the distinguishing character of the species are these simple leaves that have lobes. So I wanted to focus on that. And then this is Cainactus thomsonii, Thompson's dusty maiden, and this is on Teanaway Peak, and it was on Bill's Peak, I think. And yeah, several of the peaks that we've been to, Cainactus thomsonii has been there. So narrow distribution, but within that distribution, far more common than we previously thought. One of the interesting things has been encountering what we call disjunct species. And these are species that are found a long way from their core distribution. And 2 I wanted to highlight, these aren't the only 2, but they're kind of neat looking plants, and they really highlight this idea of disjunction. And that's Campanulus scabrella, rough harebell, and Pedicularis pulchella, the pretty lousewort. And so if we look at, their distribution, this is Campanulus scabrella. The core distribution for this species is Idaho and Montana. And then we've got a long way to go until you get to it in Washington. And it turns out it's spread out in a number of places. We've encountered in a couple of places in the Cascades. And, I look at that distribution pattern, 2 things come to mind is, wow, that is remarkable. Either these were continuous populations, over geologic time, or there's some long distance dispersal event that explains that pattern. And then there's a third possibility is that, these things are reproductively isolated from these plants over here. And this could be, there's the possibility, I'm not starting any rumors, might these things best be considered distinct species? And that would require really intensive morphological studies as well as molecular studies to see whether or not these things are diverging. So that's super neat. We've generated specimens that would support that kind of research. An even more perplexing one is the pedicularis that I showed you. So it's actually a narrow endemic. It's a rare plant in southwestern and south central Montana. Not that many populations. These are all the populations that are documented in the Consortium of the Pacific Northwest Herbaria. And then it's growing not too far from where you all, if you can go see it on Cape Horn. It's kind of a long walk. Best probably done as a backpack, although, which we did, and I'll show you a picture later. But yeah, so pedicularis pulchella, for whatever reason, somehow made it out to Cape Horn, and a colleague of mine was on snowgrass over the summer, and it appears that it might be over there as well. I haven't had a chance to take a close look at his specimen. So yeah, it's just super neat to see these strange patterns, document them, and then they offer an opportunity for people to explore them in greater depth. Okay, so this is what I would call the hand-waving part of my presentation, and that is explaining species distribution patterns when you have limited data and a lot of theory. And so there's all kinds of things that could contribute to the patterns of alpine species, the distribution patterns and the species richness patterns that we see. And just a couple that come to mind are proximity of the peaks to each other. Could it be that peaks that are close together have similar floras because it's easy for things to spread to nearby? It's easier to spread to a nearby destination than a far one much further away. Geology, we know, has a huge impact on plant communities. And the Wenatchees is a great example of this very distinctive geology that supports endemic plants and unique plant communities. So that seems like a no-brainer. Phylogeny, is it possible that some groups, some lineages of plants have evolved better adaptations to surviving in the alpine environments? And if so, maybe they're overrepresented in the alpine. And that explains, maybe they're better competitors. Maybe they tolerate cold better. Who knows? And then, what is the impact of kind of deep history? We don't have to go too deep. The previous ice age ended about 15,000 years ago. Certainly having the Cascades under huge areas of ice influenced the way that those plant communities recovered. And so we'll look just quickly at each one of these categories. And I'll start with, I realize there's a lot of numbers on here, and it's just really to be transparent about how we did things. But one of the things you can do is do what are called pairwise comparisons. So you take the flora of two peaks and you summarize the total number of species found on those two peaks, and then you count the number of species that are shared by those two peaks. And that percentage, the number of shared over the total number, is somewhere between 0 and 1. So two peaks that had 0 overlap would have a value of 0, and two peaks that had complete overlap would have a value of 1, right? So, we have been to 9, actually, I think we've been to 10 peaks in the Wenatchees, and we've done, and I can get into that later, question and answers. But so what we did is we took the Wenatchees and thought, this is a great control group. Similar geology, similar latitude, relatively similar elevation among the peaks. How does the similarity among those peaks, when we compare them pairwise, compare to other peaks that are not nearby to one another and not necessarily close to the Wenatchees? And so these are the results we got. Same number of peaks, or there are 9 peaks in each analysis. The range, and this is given as a decimal, but you can just convert it to a percentage. I think that would be an easier way to think about it. So the range is 19 to 45% similarity among those peaks, and with an average of 30% of shared species among the non-Wenatchee peaks. If we look at the Wenatchee peaks, which are much closer together, very similar geology, it's really similar numbers. The range is 15% to the most is 56%. 56% still seems pretty low for some of these peaks that are real close together. And if you know the Wenatchees, we've been to places like Bean Peak, Mary's Peak, Judy's Peak, which are all along the same ridge line. So it turns out even over short distances, you get some pretty strong turnovers in the species composition. Okay, so I talked about geology. So we did another analysis, what we call cluster analysis. It's basically the same thing. The program looks at peaks that have similar floristic composition, and it clusters them. And so you get these really beautiful outputs that look like they mean so much, like, oh, these things must be the closest. Well, when you look at the underlying information with those analyses, this was the strongest statement that we could make, was that this is one group and this is another. But what's notable is that this group here are all Wenatchee peaks, and there's only two Wenatchee peaks in this group, one of which is Bill's Peak. If you've ever been up there, it's basalt, so it's not really part of that Wenatchee Mountain geology. And then Navajo, it turns out, I looked at it the other day, it also has a strange geology relative to the other peaks. So I feel like this is, there's nothing telling us what distinguishes these two, but we can look at geology and think, well, perhaps that explains part of the differences between those two groups. Phylogenetic influence, as I mentioned, it's possible that these plant communities are shaped by phylogenetic histories. Some lineages, some families, some genera have evolved better adaptations, and that's why we see so much of them. And so that's in part why we are taking these tissue samples, so they can be, those are the types of analyses that can be done using the DNA extracted from those tissues, and that's what my colleague at the University of New Mexico is doing. I don't want to show you any data because it's not my area of expertise. There's some really cool graphics, but if I can't explain it, it's not worth showing. But I do want to show you this. This was a graph that a student put together, looking at the abundance of families across the peaks that we sampled. And again, this is on the x-axis is just the name of the family, and on the y-axis is the proportion of taxa in the alpine flora that belongs to that family. So of all of the species, subspecies, and varieties that we collected, about 15% of them belong to the Asteraceae, about 9% belong to Poaceae, and then it's Brassicaceae, Cyperaceae. It's divided between blue and red. The blue is the alpine flora that we've sampled, and then the red is the state all of the species in the state of Washington. So we wanted to know, is a particular family overrepresented in the alpine relative to its representation across the state? And so blue is alpine, red is the state. So in many of these families, it appears that they are overrepresented in the alpine relative to other parts of Washington. And another thing to look at when we look at these families, Asteraceae is the largest plant family. So this is no surprise that it's the most common family in the alpine. Poaceae is the fourth largest family. Brassicaceae is not anywhere near that big, in the plant kingdom. So there's a lot of musters, there's a lot of sedges, there's a lot of saxifrages, there's a pretty good number of Ericaceae. Some of the things that are surprisingly not represented up there are things like Boraginaceae. There was one, Salix is no surprise. I think there was one more Fabaceae. Fabaceae is the third largest plant family in the world. Actually, that's not true. It's the second largest plant family in the world, and it's about 10th most common in the alpine. And you can see it's underrepresented in the alpine relative to the rest of the state. So those are neat trends. It's great to look at these things and think about why things might be. And the last bit of hand waving I want to mention goes back to how did things get to where they are now? When you stand on those peaks and you see all these species that are terrible dispersers, and they're all over the place, it's like, well, how did they get there? They can't roll uphill, right? They can roll downhill, but I don't see them rolling uphill. Someone introduced me to this idea of what is called debris-covered glaciers. And I actually like this idea. And I'll spend a little time explaining. I'll show you a nice photo. But if you, on the front of at the snout of a glacier, there's often a mixing of soil and rocks. And it turns out that plants colonize some of the snout of many glaciers. And so there's these small plant communities. If you go to Mount Rainier and Squally Glacier, you can see this. Alaska, I'll show you a photo here. This is really not an uncommon phenomenon. And so I think of it as kind of like the conveyor belt theory. And so as before the Ice Age, you have these alpine plant communities, and then you get these glaciers developing. The only place that plant communities can survive is on the snout of the glaciers. The snout of the glaciers go down to the Puget Sound. It's warmer down there. It doesn't seem like an alpine environment, but they're sitting on top of a glacier, and the soils stay cool, and the plant communities have limited growth because of that cold. And then as the glaciers thaw, they take those plant communities back up, and then we have the dispersal we see today. And it's the alternative explanation are nunataks, or refugia, which I'll show you here in a graphic. But just to give you an idea what this looks like, this is from a paper that described this phenomenon in 2007. And here is this is Alaska. There's this glacier coming down this valley. This huge, massive area is a forest, and it's sitting on top of a glacier. And you can't see it. There's a picture elsewhere in the paper of like where the front of the glacier calves off, and it leaves these, huge drop-offs of plants sitting on top of ice. So this to me makes a lot of sense, or as a possibility. I'm not saying it's the only one, but to me, I like to think, wow, yeah, they could have come down and then they could have gone back up. That to me seems a whole lot more believable than what I think of as the Noah's Ark refugium nunatak theory, that somehow, like, all this plant diversity was able to get packed into these small peaks that sat above the glacier ice and waited for however many millennia or 100,000 years, and then it got warmer, and then things spread out from there. I just have a hard time believing that these small places could harbor a lot of diversity over long periods of time. You'd have a lot of competition. I think things would get excluded. Again, you notice I'm waving my hands. I don't have any evidence, but this is the idea. Like, these glaciers come down, the plant communities exist here, and as they retreat, you actually get upward winds going up the glaciers, and that helps with dispersing things. I'm not saying it's the only way, but it is a way that is being contemplated as influencing the alpine plant communities that we see today. And not just here in the Northwest. They've done work they've done research into this in Northern Europe and in the Himalayas. And so it turns out it's kind of a common phenomenon. All right. So I said I was going to go for 45 minutes. I think I'm close. I just wanted to summarize some of the things that we talked about. As I say, most species in the Washington Cascades in the alpine are not restricted to the alpine, and they are poor dispersers. I just want to spend a minute talking about why this might be important, that many of these plants are not alpine specialists. Is because under a warming climate, those alpine specialists, which tend to be larger plants, could displace the alpine plants through competitive exclusion. If it gets warmer, those bigger plants are going to photosynthesize more. They're probably going to generate more dispersal. They're going to be more competitive, and they could exclude the alpine specialists. Again, I don't have any. We don't have any proof, but the data that we're generating could serve as the basis for a more quantitative and empirical study. Proximity of peaks to one another is not a great predictor of species composition of a peak for whatever reason. the species composition on any one peak seems to have a unique history. Things arrive there at different times, different ways, and there's just no way of predicting what you're going to find in any one place. Geology likely influences, though, the differences that we see in these species. I mean, the geology of the Cascades is incredibly different as you go from the Goat Rocks up to the Canadians. Just around where you are, if you go south of the Wenatchee River, you're in the Champments and the Wenatchees. You go north, you're in the Entiats, which are completely different. And then we've been up further north all the way to the North Cascades, which of course is totally different as well. And then finally, deep landscape history, like those debris-covered glaciers, likely influence the species richness patterns that we see today. And it really would be neat to figure out some ways to explore that possibility more empirically. All right, so as I say, I'm really just the most conspicuous face of this effort. There's so many people who are contributing, supporting, making this project possible, and they are too many to name, but I will point out some of the members. Don Chechtel and his wife Anne have been wonderful supporters of the project. I don't think anybody else in the audience over where you are is on this list, but many of these folks are Washington Native Plant Society members, and so it's wonderful to have that support. The Forest Service allows us to do this project. They provide us with permits. I have colleagues at Western Washington University, University of New Mexico, University of Royal British Columbia Museum who are contributing to how we collect data analysis from folks here at the University of Washington, as well as John Haskins, who's also a Native Plant Society member. We've had a lot of people join us in the field on the easy hikes. Turns out some of the folks who join us on the hard ones, we met them on the way down. And then the students get to meet with people who come from diverse career backgrounds in plant biology, and it's really wonderful for both the students and the people they speak with. And so Tony Cavalieri and Gabby Chavadia is the executive director of the Burke. Helen Lau is with the U.S. Forest Service. And of course, I'm sure many of you know Laura Potash. She joined us in the field and met with the students as well. All right, I will stop there. Actually, I have to, before I show you the last slide, we do have online resources. I'm of the age where when you have a project, say, put up a website. The students that I work with are like, website? We have Instagram. So depending on what your mode of exploring information is, we have both of those covered. I don't think we're not doing TikTok. We're not on YouTube yet, and I don't see us going there. And the last photo is from Lake Edna, from around where you all are, just below Cape Horn. As I mentioned, we did that peak there, and we had a delightful experience in your part of the world and saw a wonderful sunrise from the lake there. And with that, I gladly take any questions you have. Thanks.
Well, thank you, David. That was a fascinating presentation, and I appreciate all the information about our local area. And finishing up with that picture is very appropriate. Well, I'm sure there are questions. Anyone want to come up and share them with David? I'll get us started then. David, you spent quite a bit of time on a range of peaks. What are you seeing in terms of any human impact on the flora up there?
That's a great question. I think that I provided some extra slides here. I want to keep the talk positive. But, I had this idea, as I say, when I started this project, I thought I knew something about the alpine. And there's so many things I'm learning. It is our most pristine setting, but it's not undisturbed. And so this is a photo from the WTA website. And you'll notice that there's a nice trail here coming up the mountain. And then there's someone standing off here, probably walking on some of the plants there. And then if you look here in the foreground, there's all these footprints going off to the side there. I probably did the same, taking photos of Mount Stewart. So yeah, I have to say I'm concerned about the phenomena of loving our mountains to death. Some of the peaks, the more remote ones, you don't ever see anybody. But in some of the other ones, I remember I had a conversation with Don. I was telling him I was on Mary's Peak and Judy's Peak, and he's like, "Oh, the mountaineers have a scrambling course on those peaks." And when I think about people going up to some of these places in number, different times of year, it's yeah. So they are pristine relative to many of our other habitats, but they aren't undisturbed. This is my group. I'm just as guilty as anybody else. This is us on Mount Dickerman. You can see these plants that used to be growing here on the rock. It's because people like my colleagues and I sat there and had lunch. And so it's just kind of, again, an indicator of some of the disturbance. Many of the peaks we've been to, not less than 50%, but a surprising number, used to have lookouts on them. And those lookouts left an impact. So, yeah. These are fragile environments that could be potentially, some of them, once they're altered, it's really hard for them to recover. Fortunately, unlike the San Juans, there aren't a lot of weeds up there. So when the plants go away, nothing comes back in. Not introduced.
We're wondering what the bird member of your team is there.
Oh, yeah. That is so funny. So it turns out on this day, this is Melissa Fry, and she's actually a colleague of mine here at the Burke Museum. She and her husband were hiking that day, took the day off, and we saw them. And what do you call the camp robber? Ray J. Whiskey Jack or something like that. Yeah. Yeah, it's funny. It looks like it's landing on her head.
Hi. I'm curious, what does it mean to sample a peak? Like, do you go up once in the summer, and how much time do you spend, and how do you know when you're done at that peak?
That's a great question. And, it is something that something that we tested for the first time this year. So, as I say, we look at it as the area above continuous tree line. And then we sample from there to the peak. And we roughly spend anywhere, depending on the peak, anywhere from 2 to 4 hours. And generally speaking, I feel like when we are done a peak, we have been everywhere that we can get to. I mean, we have safety obviously is a priority, but we really feel like we've covered the ground. So yeah, we just stay for as long as we feel we've looked everywhere. That being said, I'm sure that, and we only have gone once on each of the peaks. That being said, this year I was out of town, and so I had the students go back to Iron Peak, which we had visited the previous year. And I think that they found, the previous year, I think we found 45 species, and I think they found 3 that we didn't encounter. And as to why we didn't see those is not quite sure. So I'm sure that we haven't found everything on every peak, but I feel like what we call equivalency of effort is consistent across the peaks. Some of the peaks are super small, like that one that I showed you on the opening slide. It's easy to cover that in 2 hours. Mount Pew, we're going to have to go back to, unfortunately. If you've ever been up there, it's 5,000 feet elevation gain, but we just ran out of time. So great question. And, in the San Juans, I went 3 times a year, early spring, late summer, in an effort to make sure we didn't miss anything. So yeah, we will definitely go revisit a few of the peaks. Great question.
Well, David, I'll ask another one. You've got more of the Cascades to cover. Do you have a tentative list of peaks for 2024?
I do. We'll go back to the Goat Rocks. That was we got snowed out there in late August. So there's 3 peaks down there that I would like to do. If any of you have been to the Nelson Ridge, Nelson Butte, Mount Aches area, plan to get Nelson Ridge and Nelson Butte. In the Wenatchees, I'm hoping to go to Fortune Peak, which I understand is pretty manageable. I think that might be the last Wenatchee peak we've been to. And one of the nice things about the Wenatchees is they melt out early, so snow is not an issue. It is an issue in other areas. We're going to go to the north side of Lake Chelan, and there's Navier Peak and Mount Bigelow, that area, and then up to Harts Pass area. We were hoping to go to Satan Peak, and the name of the other peak nearby escapes me right now, but that was the week I had COVID, so we plan to go up there. So ideally it'd be about 12 peaks, maybe 13. That would be nice. But there's still, even that would get us somewhere like around in the mid 40s, and then it would seem like there's still huge gaps that we haven't covered. So, but anyway, that's I keep a list. I'm up to about 60 that I would like to visit, but we'll see. We'll get to 50 first.
Is there an average elevation where the alpine starts? And also, did you encounter any orchids?
Any orchids?
Yeah.
Yeah. Okay. So, yeah, I mean, it kind of goes back to, what is alpine? And I would say the lowest alpine areas is in the Wenatchees, and it's around 6,000, 6,200 feet. It really depends on the peak. Like you saw that photo I showed. So Three Brothers West, you have to get up to 7,200 feet. The same with Navajo Peak. It's like 7,000 feet before you get to Alpine. And then something like Iron Peak, I think, is about 6,200. Same with Teanaway. So, yeah, that's it. The 6,200 is the lowest. And then, up in the North Cascades, it's like above 7,500 feet, like Middle Tiffany Peak. There's one nearby there. So it's somewhere between 62 and 8,000 feet is the alpine. And orchids, no, it's the second largest plant family. For whatever reason, they're not well adapted to the alpine. It's a great question why that capability hasn't evolved for them here. Yeah, great question. Totally absent.
Well, on behalf of everybody, David, I'd like to thank you. That was very enlightening and enjoyable to talk. It was wonderful. Thank you.
Thank you very much. And thank you all again for inviting me. It's really an honor. And hope you enjoy the rest of the evening. Thanks.